a couple of questions came up about the lab work. There's good news, there's bad news, all right? So let's talk about first how to submit the lab work. There's three videos there that talk about how to submit the lab, well, not how to submit the lab work, but how to scan multiple pages into one file. It doesn't really tell you how to submit. So let's go ahead and go through it, walk through it, and go from there, all right? So over here, I'm sharing my screen, which is my phone, and I'm going to go ahead and use OneDrive. So here it is. And when you guys review this video, it's only going to show a certain section of it, so I apologize. So over here on the bottom, there is a camera. I'm going to hit the camera on the bottom, and it's going to use my camera there. And if you guys notice that the very bottom says document, whiteboard, and I think pictures, or what does it say? Business card and photos. So obviously I want a document, so I'm going to stay with the documents. And I'm going to go ahead and bring it over, and I'm going to just pretend I'm going to do this here. Even though there's some white corners already there to try to box it in, I'm going to hit the bottom button there, like it takes a picture. I'm going to hit confirm. Now here's the cool part, is that most of our homes have those recessed lighting, right? And they're bright. They're bright. So you might need to say, okay, instead of doing it this way, I'm going to go ahead and actually, now, this confirms that there is one page. On the bottom, it says add with a camera. Camera with a plus sign, so I'm going to hit that because I want to add another page. So you might want to take the picture this way so that the recessed light isn't reflecting off the paper, right? It still boxed it in, right? So I'm going to hit confirm, and it's going to allow me to keep on taking pictures until I'm done. So let's say here it goes. Let's say I'm only going to scan 3 pages, confirm, and there it is. Now, the arrow, the blue arrow with a 3 on it tells me that there is 3 documents. I'm going to hit that arrow, and I'm going to look at my paper. There it is. They're all right side up, but I don't like the cropping. So I'm going to go ahead and hit crop on the bottom. And I'm just going to crop the top a little bit more. Confirm. That looks better. That doesn't look too bad. I don't like the cropping on top there as well. I wonder if I can just, no, I can't zoom in. So there we go. That's better. That's, let's do some cropping on top there too, and the bottom. A little bit there, a little bit there. Confirm. Okay, there we go. All right. So there goes my thing, and I'm going to hit done. When I hit done, I get to name this. So example for MAC 1140, I would just use LW for lab work. And I'm going to go ahead and, let me see there. I'm just going to save it to files. I wonder if can I change it? Nope. I'm going to hit save as, boom, check mark. Now it's saved, okay? Uploading the file. So from there, I can go ahead and stop sharing the screen now. I can actually leave this meeting. So I'm going to leave this meeting, and I'm going to go ahead and share my screen over here. All right? So now I'm going to log into Portal. I'm going to open OneDrive from there. And here's my OneDrive. That's what it's going to look like, okay? And you might have to go to this top left-hand corner and hit that tic-tac-toe looking thing and select OneDrive from there. You might have to do that, okay? It doesn't automatically open OneDrive. It will open as Microsoft 365, right? And then if you click OneDrive, then it'll go to OneDrive. I click Outlook, it will go to Outlook, but this is mainly going to open as Microsoft 365, okay? So from here, I'm going to go to My Files. No, it's only going to show me my files. So let me try Home. Let me try PDF. Let me see what that does. Let's try my files again. Oh, never mind. It does go. So I call it example. So, oh boy, There's a lot of videos there. I should use like 00 or something. These are all the videos I recorded. Da 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 da. Come on! Let me just do search. Examp. Apparently it's not showing up there. All right, let me keep on going. Let's see. What did I say? Example 4. Well, none of them are that, is it? Does anybody see it? I don't see it either, so I guess I will go back. It was probably right there too. All right, I'm just gonna keep on scrolling. Actually, let's do this. It might help me there. That'll probably get the E way faster. There it is, right there. Okay, so I'm going to go ahead and download this. Download. And there it is, all right. So I'm going to go to LabWork 2. I'm going to go ahead and view as a student. So I click as student view. I'm going to hit start assignment. I'm going to hit choose file. Go my downloads. And here it is. Open and submit. Okay, so here's the thing that you need to see, is that right there. Okay, it automatically uploads as a PDF. I'm sorry, it automatically scans as a PDF. In fact, you know what? I wanted to try that too. So let me, oh, you know what? I don't know if it would let me do this because I'm being a student right now. So it doesn't see me as a student, so it's going to think that I need to log in. So it's not going to show me that. Yes. And then there are some apps like Notes that you can, if you have Canvas Student down, you could actually upload directly from your phone. Now, I want you guys to understand this. That works about 8 out of 10 times. So if you want to take that chance, you're welcome to. But I would tell you, you still want to log into Canvas and go to LabWork 2 and make sure that this detail is there. Because if that detail is not there, that means you submitted nothing. But you'll be like, but my phone says submitted. Yeah. But here it says nothing was submitted. Does that make sense? So I would tell you right now, before Friday, scan something, submit it. Right? See what happens. Now, when you get your LabWork 2 done and you hit new attempt up here, oops, let me hit cancel here. If you hit new attempt, you can put in your actual LabWork 2 and it will overwrite this thing here. Okay. Now, if you have JPEGs, so some people have done this, which I don't recommend. They'll ask Google to convert it to PDF. The problem with that is that it's so a picture from your phone, if you look at the actual size of a picture, all right, let's say that that picture on your phone that you took is probably the size of this wall. You have it convert to a PDF. It just takes that picture. It doesn't really shrink it. It just fits it to a piece of paper. So if you look at the storage or the amount of storage it takes up from that JPEG to a PDF, it doesn't shrink it that much. Okay? But if you look at the storage it takes for a PDF, it's very, very small when you scan it. All right. So if you have this humongous ARS file, what's going to happen is that I won't be able to open it, so therefore I can't grade it. So that's the reason why I bring up these scanners. Some people also take those JPEGs and put it into Word and then stretch those out and then change the Word, save the Word document as a PDF file. So there's a lot of different ways of doing it. I find that, and I know that when I start using the pen to write on your paper, I'll see it. Because it would be like, so let's take a look at that picture, right? If I took this marker and wrote on that paper, it's a pretty big print, okay? Now, if you took that picture and shrunk it to a piece of paper, how big of a print is that going to be? Right? It's going to shrink the same amount. So now it's going to look like, anybody have a string? No, nobody has a string? Okay, I figured. Oh, hello, fly. Almost had it. It would be like a string. So when I start writing and it looks like literally a thread, then I know that that's what you guys did. Especially using a JPEG and convert it to a PDF. I can definitely tell that. So that's the reason why I show these scanners. Now, I don't have a problem with you guys telling me, hey, can you better this video, adding these things into it? No problem at all. Okay? So I told you guys there's good news and bad news, right? So the good news is, for you, is that I'm going to have new students in class starting this week, right? In fact, I think yesterday was the last add drop date, was yesterday, okay? So I'm going to have brand new students starting today. They won't have a chance to do lab work 1, right? I don't think it's right for me to give them a 0. They never had the chance. And since I don't reopen lab works at all, or extend the time for lab works at all, I'm going to excuse everyone from lab work 1. Okay? Now, some of my returning students already know that, so they just skip lab work 1 anyways, but that's on them. Okay? So what I've done is this. In lab work 2, I replaced this file called example of what we know, right? Because on the first week, it was only 2 problems, right, from 1033. So I replaced this file with the answer key for lab work 1 on purpose. So that, I'm just going to download it. It's easier to do that. Just download it, open it that way. So that you guys can look at this and go and compare it to your lab work 1 and saying, did I put as much detail as he did? Or did I put more? Put more? Great. If you're like, ooh, I'm a little thin on that details thing, then now you know what kind of details I'm really looking for. Does that make sense? All right. So that's the case there. Now, the other part is, so you see the work, you see what we know. Now, in terms of what we know, notice that everything I put in what we know is quote unquote general information. Meaning it shouldn't have things from the problem. I shouldn't have x plus 5 or y equals -4 over there. However, I understand, like the first problem, you kind of have to do that. Right? Well, I guess I could have said x plus a. Right? I could say that. And saying because of that, affects the x, it's the inverse, so it would be x minus a. Right? Taking the x value and subtracting a from it. I could have done that. Right? And because I put in blue, it should have you guys see that it's part of the blue stuff, part of the green stuff, part of the purple stuff, right? But I want you guys to compare your lab work 1 to this lab work 1 and notice the kind of details that I kind of expect from you guys in terms of what we know. Is that fair? Now, again, some of you guys didn't know that. And that's fair. Right? I told you guys it's supposed to be steps and stuff like that. Yes, I did. But do you really know the extent of it? Right? You guys can't read my mind. Like I can't read your mind. So I understand. So I'm going to do that. And notice that I even took the Desmos and threw it in there. Right? so that you guys can see the power of Desmos. What's decreasing is in red, what's increasing is in blue, local max and mins are purple. Now, obviously, if you're doing a notebook paper, you can't really get into as much detail as that. I understand that too, okay? You could have said, hey, decreasing, going from left to right is going down. Increasing, going left to right is going up, and that's why I have the arrows over there for increasing, decreasing, constant, right? So now you guys know exactly what you guys need to do. You're coming in here going, holy F, what did I sign up for? I would say good luck, but also we're here to help, all right? So again, those are all there for you guys in terms of what you guys want to do. Obviously, I did mine on an iPad, so if you want to do it on an iPad, you're welcome to do that. You're welcome to do it because you have a touchscreen, yes?
It's a bit iffy to do it on a touchscreen.
But again, it's up to you, right? I've had a student that actually had a touchscreen. She actually used it that way and actually got a pen and actually wrote everything out that way too. So I don't have a problem with that whatsoever. You guys do what you guys have to do, because I can't say, you better change that MacBook out for a touchscreen or or get yourself an iPad. It's not my place to say that, okay? So there's been plenty of students that have submitted using just their regular notebook paper. I don't have a problem with that whatsoever. Some of the other questions that was brought up was, do we need to do it in order? And I said, we are in math, so yes, it needs to be in order. My suggestion would be this, one of two things. One is have a piece of paper for every single problem, so that this way it's always in order, right? Two, I would tell you to do the problems, do all the problems, whatever order you want, and then recopy that work on a separate sheet, a new sheet of paper, but now put it in order. Because you probably should give me a second draft and not your first, okay? Because there's going to be little details that you're going to be missing going, ooh, I should put this in there. Again, we're doing all of this for little Susie Q over here. Poor Susie Q. You don't see Susie Q? Do you feel bad for her? She doesn't belong here, right? So you're trying to give her steps to do so that she understands, oh, this is what I need to know in order to do this problem. Is that fair? Okay. Any other questions for me? Nothing? Any issues with Pearson and BibliU? Not anymore? We're all good? We're all in? We're all doing homework? Okay. Anybody at home having issues? Thank you for actually saying no instead of going. All right, let me stop this share screen there, and let me go ahead and start sharing screen here. Let there be screen. Hey, let's go there. There we go. Okay. All right, here we go. Now we are actually getting into pre-calc. Now, for the notes that I have this on, with any of this, just understand that I have linked the blank version of this there too. So that you guys are welcome to print it out or do the notes ahead of time so that this way you're not going, holy crap, he's going too fast. Make sense? Okay. I would try to pace myself as well so that you're not overwhelmed with this information. However, most of this is review. Yeah? Okay. Linear function. Y equals mx plus b. So that tells me that with any linear equation, I shouldn't say that. With any equation that has an x and y in it, which gives me a diagonal line, I just don't know if it's a positive slope or negative slope, my first goal is to solve for y or isolate the y by itself. When I isolate the y by itself, the number or fraction that's in front of x is my slope, and the number that stands alone is my y-intercept. True? We already know that. Now, don't forget, y-intercept is a point. And what do we know about y-intercepts again? What else? plot a bunch of y-intercepts for me. Name those points and tell me what's in common with all those y-intercepts. What is? The first number is 0, which is the x value. X is always equal to 0. Okay? X is always equal to 0. Guys, if you were with me, which none of them answered this, I would say to you that you need to remember that y-intercept, x is equal to 0, you need to remember that for the rest of your math career. So if pre-calc is your last class, then that's all you need to remember to the end of this class. Which also means that the x-intercept, that means y is equal to 0. You need to remember that for the rest of your math career. Okay? All right. So with that being said, since we need a point and a slope in order to write an equation of a line, we need to find slope. Well, we actually know slope, not just these two. What's the third one that talks about slope? But we're not going to use it in linear functions, though. Bless you is the wrong answer. I don't know why you would call that. Remember, it's the difference quotient. Difference quotient was the other way of finding slope. However, we won't use it in linear functions. This is the slope formula, right? Change in y over change in x. This is the average rate of change, which is basically the slope formula, but changed into function notation. Don't worry, there will be actually writing in here. Increasing, decreasing. You guys already know this. So when a graph goes from left to right and it's going up, it's increasing, but better yet, the slope is positive. Going from left to right, if it goes downward, then it is decreasing, but the slope is negative. And if it stays constant, the slope is 0. This, the way I describe this, is like skiing on a flat surface. It's 0 fun. So that's why the slope is 0. If it's a vertical line, what's the slope? Undefined. Just like skiing on the side of the Grand Canyon. Ah! Wait for it. Splat, right? So by the time they realize that my body's down there and they find it, my body's going to be undefined, right? Like as if it never existed. And don't worry. I know that this seems to be like a lot to copy, but understand this, guys. Remember that this video and these notes will be posted as well, right? So it's not just already posted, but it will be posted again. All right? So if you're like, crap, he moved on and I missed a part, it's okay. And probably today or tomorrow, I will send out invites for a remind, by the way. Okay? So to see if it's a linear function, basically I pick 2 points. So if I'm giving a bunch of points, let's say a chart of points, right? I'll pick 2 points and find a slope. I'll pick 2 different points, find their slope. If it's the same exact slope, then I know that that table is a linear function, right? So if I look at this table right here, I think you guys can see here that this is a linear function, or no? Yes? So, but in terms of what I hit here, so if I pick these 2 points right here, 20, 0 and 15, 3, and if I was to find a slope, what's the slope? Hello? Close. Wouldn't it be negative 3 over 5? Because I would have to do 0 minus 3 over 20 minus 15. Because it's changing y over changing x, right? So if I pick 2 different points, like 20, 0 and 10, 6, what is that slope? right? So if I look at the two slopes, they're the same slope, so therefore I know that this table is linear. But you can also tell from above that these differences is this, while the right, the difference is this. This will tell me that that's linear, because everything is the same difference or same sum. Questions there? Nothing? Are we sure? All right. So we know y equals mx plus b. That's the slope-intercept form, so I shorthanded to SIF. Yes? This equation on the right is the point-slope form. Okay? The reason why it's called the slope-intercept form is because that equation gives me the slope and the y-intercept. While this equation here is a point-slope form, meaning it gives me a point, x comma y, and a slope. I short that to PSF, so I think that's pronounced as PSF. About right? I don't know how else to pronounce PSF, so PSF it is. Okay? So this is talking about supply and demand, or we could even call this, so this is called supply demand. We can also look at this graph as cost versus revenue. Right? They are similar graphs, right? So if I call this red line right here my supply or my cost, and I call this line here my demand or my revenue. Hopefully nobody's revenue works that way, going directly downward. All right. So what can you tell me about this point right here? This point is called what? What is that thing called? That is called the break-even point. It's called a break-even point because the demand and supply are the same. They're equal. Okay? How about to the left of that break-even point? What can you tell me about the left of the break-even point in terms of the demand versus supply? Don't make it more difficult. The demand is greater. The demand is greater because the graph of demand is higher than the supply. And to the right is the other way, because the demand line is lower than the supply, so the demand is less. Okie doke? So if I wanted to know, if I was given these two equations, supply is negative 250 plus 50p, and demand is 1,000 minus 75p, how would I find the break-even point? You set them equal to each other. So for the break-even point, and you would solve. Thank you. What, that makes it 750 then? Thank you for pointing that out. Huh? Oh, my goodness. You're like, no. I'm not mathing today. Is that better? Thank you. It's funny because I don't know why oh, got it. And what does the P stand for? So that means this is supposed to be 10 what? Hopefully dollars over in the US. If we're overseas, then maybe others. Any questions on that? We okay? Are we sure?
What if they just want you to make the equation yourself, give you a bunch of numbers? Will they tell you which is supply and demand and price, or will you have to inference it?
Like
Like on a test question.
on a test question, if they were to give you a graph, you mean? So with the graph, they will tell you, they'll label which line is the supply and which line is the demand. They'll definitely do that. The problem with the exam, though, is what? Both lines are going to be in black. So that will be the downside. So you kind of have to follow it. And then based on the x value, I should get 10 because I just graphed those random Desmos. So it should give me 10 anyways. That's why I was kind of confused on the math myself until someone told me that I wasn't mathing very well, right? So yeah, so on the exam it will give you that. So you don't actually have to find the equation, okay? Because from there, but I could find the equation, right? If I knew what the y values were, which I do there, so I could take this point right here. If I had to find the equation of this line, to find the equation of a line, I need two things. Thing number one, I need a point. Thing number two, I need a slope. So if I just pick 2 points, maybe that point and that point, right? And say, okay, let me find a slope. Now from that, I just pick a point. So I can pick this point right here or that point right there and plug it into the point slope form, and I can find the equation of the line. Okay? So I can definitely do that. Any other questions? I'm pausing, waiting. Nothing? Fine. So building linear models. So this is where I'm going to show you guys how to do this on a calculator. I know that some of you guys are going to use your TI. Some of you guys are going to use Desmos. Please pull that out. Oh, I didn't show that there, but I will talk about it right now. So on a TI, you'll have to create a list. How do you do that? Anybody? Just take out your phone and oh, you got your TI, okay. How do you make a list? hit stat, and hit edit. Don't worry, Desmos. I got you guys. I'm gonna make sure the TI people are there. Do you guys find it? So stat, edit. So stat 1. Now you have L1 and L2. Under L1, put your X values. Under your L2, put on your Y values. Okay? So go ahead and do that. For Desmos, first of all, you need to be in the graphing calculator. You're going to hit the plus sign on the top left-hand corner. And you're going to hit table. Anybody that's new, just so you guys know, I don't have a problem with you guys using Desmos test mode, which is a blue logo, if you guys want to use that. Again, is there an advantage of using one over the other? No, there's no advantage. The only advantage is that Desmos is a lot cheaper. A lot cheaper. Okay? So here you will enter your X values, 0.9, 32.6, 33.8, 32.9, 33.8, 33.4, 32.2, oops. 32, 31.5, 31.8, 29.9, 30.9, 33.4, and 33.2. Okay? And then go enter the Y, 812, 732, 822, 753, 824, 770, 778, 732, 735, no, 690, no, bless you, 690, 668, 604, ooh, 639, 761, oopsies, I did something wrong. Where did I go wrong? 32.9, 32.6, 33, 8, 32.9, 33.8, 33.4, 33. There it is. Can I do this? Ah. Oh. Forgot the 33.1. There we go. All right. So in Desmos, if you guys hit that magnifying glass on the bottom left-hand corner there, everybody see that? If you guys hit that, it will show you your points. TI, you'll have to go into the graph and do other things. Okay? So, are we still entering points? Okay. Right. Oh. Plus sign, table. Yep. Remember, your calculator is going to have to be Desmos test mode. You won't be able to use regular Desmos, right? Trying Desmos?
I am. I never even heard.
Plus sign?
I did it right here.
Oh,
I was
okay.
that one.
Perfect.
I can try on this one.
I know that everybody in class is doing it. Hopefully you guys are doing it at home as well. Oh, you're just checking your. Keep on checking it. And then I will. Are we done entering all the numbers? Yes? Let me see if that's right. That's not what I got. That's definitely what I. Oh, because you went backwards. That's why. X, Y. Come on. Come on. No wonder why you got it backwards. Is that right, done entering? Okay. So hit stat, calc, linear regression, L1, L2. Calculate. Wow, you did get a different number as mine too. Hey, do this for me. Double check your
Alright.
list and make sure it's the same. Are we done? Entering their data points? Okay. So with TI, oopsies, you lost my face. Here I am. So with the TI, you're going to go back into stat. So hit stat again. And you'll see that your quote-unquote mouse is highlighting the top there. Where's the top? It says edit. So move to the right with your right arrow under calc. So calc is highlighted. And then scroll down to lin reg, which is linear regression. AX plus B, and hit enter. On the Desmos, notice that what we have here is x sub 1, y sub 1. Yes? So the way we do this is that we're going to type in y1. So y1. And it says there's 15 elements. Let me make sure there's 15 elements here. 2, 4, 6, 8, 10, 12, 14, 15. Awesome. And it's not equal to, but approximate. What is the approximate sign? If you hit ABC, there's that approximate sign right there to the right of that squiggly bracket. Then you're going to say, oh, sorry, M x1 plus b. And there is my slope and my y-intercept. So on the TI, you guys should get your A should be 57.3455, and your B should be negative 1120.75. Is that what we got on the TI? Unless you type it in backwards, then not so much. Did we figure it out? Why?
I checked it, it's the same.
So what the heck happened?
I got the right numbers
I'm trying to figure out where he went wrong. See, I can't use the TI anymore because I'll have to. I would need these glasses over here. Because she needs new ones anyways. Oh, you fixed them?
Yeah, I think so.
Okay, hit that. Toggle to the right, calc. Scroll down to linear regression to 4. Enter. Enter. I feel like you're missing a point.
I just.
Your glasses are missing a point. Is it that 30? Huh? I know. That's why I say you need new glasses.
How many chances? Do you know once you reset the zoom?
Huh?
Do you know once you reset the zoom? Because I think
It worked? Oops. But you can just do that.
Oh. Oh. Cool.
What did they do? Did they miss a point? No?
Yeah, same thing. It's just weird.
Go ahead.
There it comes to that.
Yeah.
But then if I do it, mine comes to that. But I have an older one.
Hmm.
They're not in like degrees instead of radians or something, are they?
That shouldn't matter. Even their R squared is off. He has 15 points. Sounds good. The numbers are the same. Good old calculator.
In my calculator, it's like.
Well, I wouldn't call it stupid. Yeah, that comes out the same. I'm really wondering why, though. It's under L1, L2. So you're using the list of L1, L2. I don't know. You got it? You found your error? Did everybody else get the right answer? Huh? Stat, calc, linear regression. Boom. There's your A, B. So it's in the form y equals ax plus b. Here's your A. Here's your B. But you need to find your line, right? So there's your A, there's your B.
Is it right though?
Mm-hmm. You guys are so funny. So for the TI, I don't have this down here for this, but for the Desmos, the steps are right here. All right. So this is called a linear regression. That's why on your TI it says lin reg. Okay? And it's an AX plus B, where in the Desmos I can specify what I want. So I can call the M, I can call the B, B, so that I don't get confused that the A is the M and the, well, B is still B. You know what I'm saying? So, so if I was to write this equation, this is going to be y is equal to 57.455 x minus 1120.75. So that will be the equation of my line that, that was drawn, which shows there. Any questions there? So if you guys go back into your stats here, guys, for your TI, and under calc, you're going to see linear regression, quadratic regression, cubic regression, natural log or log regression, and exponential regression. So those are the regressions that we're actually going to do in pre-calc. So all of those. So understand that with a TI, it's always stat, edit for your list. Your X is usually at L1, your Y is usually L2. And then from there, you'll go back in the stat to calc and then pick those regressions. All right? With the Desmos, however, the downside is that you're going to have to remember the basics of those equations. You're going to have to type these equations in, right? So you're going to need to kind of practice those equations, okay? Which I think is a good idea anyways, because then you know what those equations are supposed to look like, all right? Any questions there?
That's on the notes, right?
For the Desmos, yes. Yep. Questions? Oh boy. Now we're getting to the good stuff. And I don't think I'm going to finish these notes, but it's okay because we still have Thursday. Oh, by the way, just so you guys remember, next Tuesday is a study day. I mean, school is open, but there's no classes. So you're supposed to come to school and study.
Will you be here?
I'm sure I'll be here.
Like,
Most likely in this classroom or in my office, which you will find it in Canvas homepage. It will say lectures and exams, Carter. There will be a map of where this location is and where my office is. All right, so quadratic functions. You guys know these as parabolas. You know the standard form, ax squared plus bx plus c, yes? Now, if the A is negative, is a frowny face. If A is positive, is a smiley face. And every single parabola is symmetrical through a line called the axis of symmetry. And through that axis of symmetry will be your max or your min. So if I was to draw that, so that would be your axis of symmetry, your AOS. And where that hits is called your max or your min. Or better yet, is known as your vertex. Okay? So to find the axis of symmetry, so if you're given in standard form, the first thing you're going to find is the axis of symmetry, which is negative b over 2a. And the x is really based on, this x value here is based on your equation. So if these x's were t's, right, at squared plus bt plus c, then this would be t is equal to negative b over 2a. Is that fair? Okay, we got to be careful with that. After we find that axis of symmetry, it gives us the x value of the vertex. To find the y value of the vertex, we'll have to take that x value and plug it into the equation to find my y value, so that I have the x comma y value of that vertex. So first, find the axis of symmetry to find the x value, plug it back into the equation to find your y value. This looks complicated, but it really isn't. And then you'll find your vertex. Questions so far? Nada. All right. So let's pretend that I'm given this in standard form. Right? I got to first find my axis of symmetry. Since these are x values, I can say x is equal to negative b over 2a, which is negative 4 over 2 times 2. So x is going to equal to negative 1. So the equation for this line is x equals negative 1. Then if I want to find my vertex, what I'll have to find is the f of negative 1, which is my y value. So that's going to be 2 times negative 1 squared plus 4 times negative 1 minus 8. And that's going to equal to what? That's 2 minus 4 minus 8. Was that minus 10? So therefore, my vertex is going to have the point negative 1 comma negative 10. Is that fair? There's another way of doing this. We can convert the standard form to vertex form. So why is the vertex form cool? Because the vertex form gives us the vertex. H comma K is your vertex. But notice that the sign of the H is flipped. Just like in transformations, what do we know about things inside the parentheses? It affects X. What else? It's inverse backwards, right? So this is inside the parentheses. So that means the sign for the H is going to be flipped. Be careful. So it gives us a vertex. So it tells me the point of the max and min. So these are going to be both H comma K. Ooh, that's hard to see. Sorry. Let me do this. Hold on. There we go. There's like a little scratch off. Oh, I see H comma K now. From there, we can find the axis of symmetry. So we go backwards. And the axis of symmetry is just the x value because the vertical line is all, the x stays the same. So it's going to be x equals h. So in this example, so therefore my vertex is -5, comma, -7. And the axis of symmetry will be negative x equals -5, which is the x value. Is this a smiley face or a frowny face?
This is a positive parabola.
It's a smiley face. So the A is the same. Notice where the A is. It's on the outside, right? What's on the outside? +2. So that's going to tell me it's a frowny face. Okay? So remember, when we did transformations, this is what we did. This is the form that we usually see it in, right? So this is going to be a smiley face that's going to be tall, twice the height. Because it's outside of parentheses, so it affects the y value. So it's going to take a regular parabola and stretch it twice as high. Okay? So there's going to be a vertical stretch to it. So the question is, how do we go from standard form to vertex form? So here's the issue. Remember when I was talking about completing the squares? That's more useful and quadratic formula is useless? Yes? So here's the thing. We're going to convert this standard form to vertex form so that we don't have to do the -b/2a. The problem with this, however, in completing the squares, number one is that in standard form we had a non-zero side and a zero side, didn't we? That means we had two sides, right? And the other side was a zero side. This does not have a zero side. Understand? So meaning I can't kick the cheater out the house. The cheater is going to have to stay inside the same house. Okay? So, here we go. So here's what I would do. So because we found that C has been cheating on us, we have to put him in a different room. We don't want to share the same bed with him anymore. Okay? They've been cheating on the family. Let's put him in the doghouse. The dog gets to sleep on the bed. He's going to have to fit in the doghouse. So similar to completing the squares, all we have left is the A and B, right? But with completing the squares, what is necessary? What was step 1? What was step 1 in completing the square?
The b value divided by 2 squared.
Before that. That is like step 3. Because step 1 was what? And then step 2, we kicked them out of the house. Step 3 was to find a new C, right? Kick the old C out of the house, find a new C. But what was step 1? What letter is this in sign language? Has to equal to 1. Is A equal to 1? So because there's no other side, I'm not going to divide. Yes.
You have to factor.
Yes, I'm going to do a GCF instead. All right? So here we go. Ready? So this is, I'm going to factor out 3, leaving me with x squared minus 2x plus 5. So notice that my A is now equal to 1. Right? Step 2 in completing a square is usually kicking the OC out of the house, but since we can't kick them out of the house because there's no other side, we just kick them to the doghouse in the in the kitchen, in the basement, right? So now we're going to find a new C. And you were just saying that C is equal to B divided by 2 squared. What's my B? -2. So I said to you guys, do the work. What's -2 divided by 2? -1. And that's going to give you 1. So I'm going to have to add 1 here. So when we did completing squares, because I added 1 there, I added 1 to the other side, right? But since I'm on the same side, I can't add on the same side. So think about a seesaw. If I had a seesaw, if I add 5 pounds, if I add a pound on this side, I get to add a pound on this side, right? But what if I can't deal with these guys? So I'm only going to deal with my own side. So if I add a pound here, what do I have to do next? Well, I don't want to talk to these guys. So I don't want to add a pound over here. Could I just remove a pound from this side? Right? If I add a pound and remove a pound, I'm still balanced, right? Okay. But here's the problem. What we see here is that we added 1. But did you only add 1?
No, you factored a 3.
I factored a 3 out, didn't I? So I really added 3. Everybody see that? So when I added this 1, I factored out a 3. So really I added 3 on this side. That means I got to subtract a 3 from the same side. Okay, so let me put this right here. Let me do this right here really quick. Boom, boom. Move this up. Because I want to make sure that you guys understand that this is the 3 times 1. Okay? That's how we got that 3. Everybody see it? Because I added 1. 1 times 3 is 3. So if I was to, because I only have one side, if I add 3 pounds on this side, I have to subtract 3 pounds. So I'm still balanced. Okay? Now I have the factor. So f of x is equal to 3. This is going to factor out to be Does everybody follow? I don't know why I wrote it twice. Questions? None at all. If I was to give you a problem, you can do it just like that. Yes, sir.
What's here plus 2?
The 5 minus 3. That's why I want you guys to ask questions. Any other questions? No other questions? Nothing at all. Are we sure? Oh, look at this. Look at this. Finding intercepts. Huh. That's weird. I think I heard this before. Right? Y-intercept, x is equal to 0. So I'm really looking for f of 0. X-intercept, y is equal to 0. That means I'm saying the y value equal to 0. So if it's a quadratic equation, I can use a quadratic formula. I can factor the side, and I can also do completeness squares, right? Now, in the quadratic formula, that I said useless, the only useful part of quadratic formula is what's inside the square root, the radicand. That's called a discriminant, right? Which, if you guys think about it, would make sense. Remember how I told you guys only put this in your calculator, right? So we only put that part in the calculator. If it came out to be negative, what kind of roots are we going to get, or what kind of solutions are we going to get? Imaginary roots, right? Or imaginary solutions. How many of them? Don't forget that there is a plus and minus here. Maybe 2. So 2 imaginary solutions. If it was positive, how many solutions will we get? 2. What kind of solutions? 2 real solutions. Bless you and gesundheit. What if that came out to be 0? How many solutions will we get? 1, because it's plus or minus 0, right? So it'd be 1 real solution. So that's what the discriminant is really telling you, and that's all it is. So roots. Roots just mean the solution, which if you guys didn't realize this, and I know that you guys didn't realize this, I'm going to show you guys something. So let me go ahead and X this out and X this out, and let's plug in y equals 2x squared minus 5, okay? When we were looking for solutions on quadratic equations, what we're really looking for was the x-intercepts. More importantly, these are also called roots. So when we found solutions, they're really called roots. Why are they called roots? Because they're x-intercepts. So when you think about this, that's why in here we're calling them two imaginary roots. Meaning you wouldn't see the x-intercept. Okay? So if I did this on the calculator, it'll look more like that, where it does not cross the x-axis. That's why there's no roots. So this part right here is just a summary of what I've already talked about. Standard form, we find the axis of symmetry first, then find a vertex. If we're in a vertex form, we find the vertex first, then the axis of symmetry. Right? Intercepts, we got the y-intercept, x-intercept. Oh, sorry. Y-intercept, x-intercept. Y-intercept, x is equal to 0. X-intercept, y is equal to 0. Okay? So anytime we're graphing a quadratic function, those are the things you want to do. Right? Here are their steps. Here are your 4 steps. Okay? Find out if it's smiley or frowny face. Find your vertex and the axis of symmetry. Plot those. Now, find your intercept. So here's the thing. If I have a parabola, right? If I have this axis of symmetry, that means whatever point I plot on this side, whatever distance that is from the axis of symmetry, same distance, same y, is going to be on this side. Does that make sense? That's why it's called the axis of symmetry. The distance from this point to the axis of symmetry is also the same distance from this point to the axis of symmetry. So concavity, once I have the axis of symmetry and the vertex, I know where the bottom is or the top is, and I know the center. And then when I plot the y-intercept, I know the other side of the axis of symmetry. Does that make sense? So that gives me 2 more points. The x-intercept will also give me 2 points. So now I have 5 points to graph the parabola. Does that make sense? Right? Then it says use symmetry to plot the other points. So essentially, with this, I should have a total of 5 points to graph my parabola. All right? Since time is up, I don't mind graphing this in the next class so that you guys have it. Or we can talk about or walk through it. If you guys want to do it on your own to kind of practice it, you're welcome to do that. But I would tell you that, so when I look at the lab work, before you guys go, when I look at the lab work, 6, 7, and 8, you're going to need the work from 4.4, 3.6. Question 1, if you guys see if you guys can do that, because that's talking about max and min. If you guys remember how to do that, right? So you had to draw your fencing. If it's 4 sides or 3 sides, how much does the fence cover versus the area, maximizing the area, all right? So number 1, I'll do this problem on Thursday, go over 4.4 so that there's going to be some problems there that will kind of cover how you should think about problems 6, 7, 8. Is it 6? Yeah, 6 to 10, all right? And then I want you guys to look at the lab work and ask whatever questions that you guys need to ask, okay? Now, some of the comments I got was, sorry that I didn't hand in the lab work. It took more time than I thought. I hope that you have adjusted that time because I'd rather that you spend more time on the lab work and less time on MLM because the lab work is going to help you in this course way more than MLM will be, okay? So other than that, ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. I will see you guys on Thursday. Later.